My, is there ever some interesting stuff going on with space weather? Sunspot number up to 260 something? And we've got a new solar flare player as well, so all eyes have been on that sunspot group in the southwest. And get ready for X-class solar flares, because the likelihood of seeing one of those is getting higher and higher as that sunspot group has not degraded. We've seen a huge uptick in sunspots once again since yesterday. So we've got a huge number of filaments, another coronal mass ejection on the way, with one to arrive late tonight, early tomorrow morning. So it could really be here at any moment, folks, because we can be off by a lot when it comes to the speed of CME impacts. So some extremely active areas there on the map, and some very strange anomalies showing up. I don't know if you're seeing that or not, but look right in here. That is a weird one. And I have no explanation besides it's probably a series of dead pixels on the SDO, as it is certainly in a stationary location. So it's some problem with the aperture for sure. And so here's the, we're using the SDO browse data feature here. There's the full disk view in 171. And yeah, we've got this new flare player over here in the southeast. So it's produced a double spike M-class flare in the past several hours. So, of course, and it's in proximity to the limb as well. So we've had a huge uptick in the likelihood of an X-class solar flare. Exciting stuff, and thanks for tuning into the Smash News Network, least busted name in news. There it is. It's only the world's most comprehensive daily space weather content and most detailed solar imagery. So yeah, here's that new solar flare player. It's already produced at least 2 M-class events. And here we've slowed it down to 15 frames per second. It happened at about 1600 Universal Time, or it started. And that double peak flare lasted for several hours. Again, don't discount this sunspot group as it is approaching the limb, and that is one of the more rowdy sunspots that we've seen during this solar cycle. So it's the likelihood of an X-class flare is approaching 80-90% as that sunspot group approaches the limb. It is not yet in the state of degradation, so it's still chilling over there. And so yeah, now let's take a brief tour here. We're going to take a brief look at the ultra high res imagery. That's the 4800 by 4800 SDO imagery. A fantastic voyage tour of the lower corona, ultimately. The lower corona, or quiet corona. That is ionized iron gas. And yes, it's a very bumpy environment. A very bumpy environment indeed. So there's that new sunspot. A great example of how a sunspot doesn't have to be big to be a major flare player. Now, as far as what's going on Earth, we've got, like we reported yesterday, that 5.4 magnitude quake, not necessarily signaling a new eruption there at Barabunga, but nonetheless showing up on the list just by way of having a 5.4 magnitude quake. Pagana also exploding, Luatobi, Semeru, Dakono, Ruang, you'd not be wrong to say Ruang, is erupting following a strong paroxysm. Popocatépetl exploding. Sancho Guido, Fuego, and Sabancaya, but the real story is going to be earthquakes when it comes to earthly stuff, because a massive number of foreshocks, and then 2 6+ magnitude events, one off the coast of Taiwan and one in a highly populated area. So they were zoomed in. All right, so I'm going to zoom out here, and it's going to show you population density. So very heavily populated areas there, and just off the coast of that location. So very heavily populated there. There's the population density of the island of Taiwan. And yeah, so there's the first quake. And then less than 6 hours later, there was a second quake right in the highly populated area. Check it out. That's Xiaofeng Township. And look at how populated that is. Let me zoom out here. Xiaofeng Township. Lots of people would have felt that 6 magnitude quake. So a great example of foreshocks. Only 6 minutes before the 6 magnitude quake right in the city was a 6.1 off the coast. So, and there were a number of foreshocks there. So a prime example, again, there's the one in the city and only 6 minutes before off the coast. Now, if you look at the list of quakes, you'll see multiple quakes of a 5 and greater magnitude, like a 5.3, a 5.1, a 5.2. So lots of pre-quake warnings there. Also a 4.6, 4.9, 5.2, 5.6, 4.9, and so on. We've also got other activity here happening at the same time south of Indonesia. Then you've got a 5.1, a 5.0. Also Indonesia. Wow. Major plate motions happening over there. Micronesia had a 5.2. Taiwan had a 5.1. Micronesia had a 5.5, 4.5. China had a 4.6. Way off in the continent of Asia. And then a 5.0, and then a 5.8, and then a 5.0. So, by the way, folks, those 6 magnitude quakes could be foreshocks as well. Let's hope not. If they're foreshocks to a larger event, that would be unfortunate. So, but we do see at least one aftershock there of a 5.2. So, yeah, pretty interesting when it comes to quakes. And let's take a look at some more solar imagery here. But first, some more data. So the 10.7 centimeter radial flux needs to be updated because it's currently at 217, and there's no way that's not going to rise with 260 plus sunspots. There is the 1-year graph from Solon.info. The black line represents a radial flux, and the red line represents a sunspot number. Again, sunspot number is going to be at like 260, and you will see some differences depending on who's counting the sunspots. I ain't getting into it. It's the daily space weather. Oh, 227. There you go. 227 is the new radial flux number, not 217. 227. And again, we're expecting, well, it looks like NOAA is expecting some geomagnetic unrest there. They're not saying it in their description, but you're seeing some geomagnetic unrest on the KP breakdown here. So looks like NOAA is sort of half-heartedly agreeing with ESA and with our channel. So although you don't see it modeled on their Enlil spiral, they are looking for some possible geomagnetic unrest. So for aurora chasers out there, that should be good news for you. Better news is what we're saying and what ESA is saying. Here's the ESA Enlil spiral. And as you can see there, multiple events likely to be on the way. So there's also a coronal hole high-speed stream just following that. And it looks like they may be, yep, they are indeed modeling a coronal hole high-speed stream there, kind of mixed in at the tail end of those CME impacts. And that's legit. Yeah, that's consistent with our forecasts, although there is another CME, I think. Yeah, there is one more CME. That'll be showing up on the 24th. So we'll see. ESA is going to update that. Watch. You watch. Tomorrow there'll be another CME on ESA's Enlil spiral. Now, as far as the current geospace, it is very calm, geomagnetically speaking, for planet Earth. There it is out to 12 Earth diameters, and we have a very diffuse and slow solar wind. So when we do see a signal come in, it's going to be a legit signal. There's going to be an impact by that CME. But that's the last 4 hours. Very calm. Things have reached static equilibrium without a lot of plasma, and hence not a lot of magnetohydrodynamic pressure. Next is Earth's magnetic moment from the ground for the past 4 hours. And again, you're going to see this light up in the coming 12 hours with multiple CME impacts. And actually, there's going to be some stuff going on for probably more like 36 hours, but it's going to hit in the next 12 hours, and then it's going to continue to hit for like a day and a half. KP index is currently at 1.67. Again, very slow and very low is the solar wind. So ACE is only showing, look at that, 0.1 protons per cubic centimeter, and a solar wind speed here below 400 kilometers a second. To Discover, the other spacecraft we use orbiting Lagrangian point 1 to measure the solar wind, a little bit faster there, quite a bit faster at over 500 kilometers per second, with a solar wind density of just under 7 protons per cubic centimeter. Our GOES magnetometers are smooth. You can expect to see some gyrations in the GOES magnetometers in the coming 36 hours because, like I said, multiple CME impacts followed by a coronal hole high-speed stream and another CME impact. So like 3 more events are on the way, not counting the coronal hole high-speed stream. Next, the magnetic sector of the heliosphere. So there you go. That's North Pole magnetic sector for Earth, N stereo A, N stereo B. So what's great about this imagery also is that it shows you the location of stereo A in terms of how much angular view you get. Stereo A would be the little plus sign to the right of the Earth in that image. Stereo B would be the little plus sign to the left. It's actually a satellite icon. Stereo A over there to the right, stereo B to the left. North Pole sector to continue here for at least the next 24 hours. Tomorrow, for daily space weather, we'll still be in a North Pole magnetic sector. Unless we decide to leave the solar system, galaxy, universe, plane of existence, etc., then maybe not. So, here is our line of sight field plot, and that's a lot of information all at once. Solar B field, polar fields, and photosphere magnetism, all depicted for the past 4 days. Probably the most rich piece of data you could possibly look at. Next line of sight coronal hole plot. We've got a bunch of South Pole coronal holes here, exactly as forecasted. And you can expect the uptick in coronal holes to continue because we've had a shortage of them throughout solar cycle 25. So they'll continue because the polar field reversal process has to occur. And as it occurs, the coronal holes cross the solar equator and cause high-speed winds to show up at planet Earth. So that's the coronal hole high-speed stream and the location of the polar fields throughout the pole reversal process. Like I said, sunspot number is over 260 here. It's at about 265 sunspots. 265 sunspots. So, and like I said, also the likelihood of a large solar flare extremely high, especially in the southwestern limb. Now, the likelihood of another large flare from those southeastern sunspots is lower than those setting groups in the southwest. Those groups over there in the southwest, they're going to show us an X-class flare, if not multiple X-class flares. So don't be surprised to see that happen. They have not been degrading sufficiently to make me confident they will not produce X-class solar flares. So let's look at coronal holes here. Yeah, there we go. Coronal holes, that's a thing. Yes. That is an important thing to understand. Coronal holes, they are super crucial to the solar sunspot cycle. And our regular viewers from the Smash News Network, least busted name in news, can certainly attest to the accuracy of the channel's forecasting. So 211 angstroms is the ultimate wavelength through which to view coronal holes. And yeah, that ain't half bad. Now, as far as sunspots go, let's take a look at these, especially these setting groups. Now, that is just for today. Oh, yeah, that's good times. That is April 22nd only to date. So look at all the deltas there. Those sunspots are already extremely unstable. And we've got, to get me off the screen, Yeah, and yo, check it out. Wow. All right, let's zoom in a little bit closer here. Dag. So that is, I mean, we don't even break this feature out very much, but that is an X-class flare waiting to happen, folks. So first of all, look at this rapidly. See, sunspots sometimes move at different speeds to each other. So look right in here. Look at that group rapidly advancing to the west, closing in on that North Pole umbra. That trailing South Pole umbra is speeding right toward this North Pole umbra, creating massive deltas. So, yo, that's serious stuff right there. X-class solar flare in the forecast. Look at it. It's overtaking. It's basically smashing into that opposite polarity sunspot. So that is exactly what you would expect to see. And yes, solar flares are 100% forecastable. I'm not sure how long we've known about this, but for a long, long time, we've known that sunspots and their magnetic fields, they give us pre-warning, almost like an earthquake foreshock if you know what you're looking at, and it's magnetic shear. So it's super exciting to be able to do that. But again, we've been able to forecast solar flares for like 2 decades. I think somewhere around the early 2000s is when we became, let's see, the SDO went up in what, 2004? I'm not sure if we could do it before that, but I suspect we probably already knew about it. So we wanted to look more closely at the photosphere. Now, speaking of the photosphere, here's the area just barely above it. So these are carbon lines. That's 1600 angstroms. And where you see brightening is where things are getting exciting. So look at all the brightening happening in there. That is a lot of carbon. A lot of ionized carbon there. So all those white areas, that is a whole bunch of very hot carbon appearing on, on the SDO's imagery. Anyway, we'll get to CMEs here in a minute. But first, I'll reappear. Yeah, there we go. How about energetic particles and solar flares? Proton flux is flatlined. The GOES X-ray flux, again, there's been that double M-class event. And the second one was the long duration one. The first one was a rapid onset and then a very slow decline. Next, our solar system forecast. And we already showed that, so we're not going to go back. Solar system forecast is next. Here's the 1-week forecast for the solar system. That's where things will be in 7 days. Don't forget to check out our Ask a Particle Physicist segment. We'll be talking about the barycenter, perhaps, if Eugene decides to take that question. Eugene the philosopher will be maybe talking about the barycenter and whether or not it's in charge of solar sunspot cycles. So our next slide here is what's going on over our head. We've got Mercury and Venus setting. Once again, if you're up early in the morning before sunrise, you might see the rising of Saturn and Mars, heralding the rise of Mercury and Venus. So 4 planets there in the early morning skies pre-dawn if you want to check that out. The astronomy photo of the day today is smoke rings. And what causes them? Well, the right humidity, pressure, just like it's basically weather. I mean, it's basically weather interacting with volcanic gas and ash. So, you know, if the vent blows the gas out at the right angle, a vortex gets created because of the heat, which causes it to rise, and then a ring forms. And if the wind speeds are slow enough, just like a persistent contrail, it might stay in place. And these things are actually surprisingly stable as they rise up. You can see there's like a certain angle that's like the right angle based on the amount of pressure, the composition of the gas, how much ash, the humidity, the pressure, the temperature, all those things figure in. But that's how you get them in an awesome crescent moon there as well. That's the astronomy photo of the day. That's from Etna, I suspect. Yeah, Mount Etna, of course, located on at Ganges, Sicily. Now, yesterday we failed something. We showed an eclipse image instead of this crazy image of Jupiter. So let's show that today instead. Yeah, that's the Juno spacecraft flying just a couple hundred miles over the cloud tops of Jupiter, to the point where there was massive amounts of radiation exposure due to Jupiter's version of the Van Allen belts. And the closest photos ever taken of Jupiter's cloud tops, obviously. And then you have a polar vortex. So let me actually pause that. So right in there. Now check that out. That is a polar vortex, just like we get, in northern hemisphere and southern hemisphere winters. You get a polar vortex. And of course, Jupiter has like a hexagonal shape to the cloud cover up there. And there you can see some extremely low pressure zones right in there. And just a quick reminder that the Great Red Spot actually isn't a storm per se. The Great Red Spot is actually a high pressure zone known as an anticyclone. So the Great Red Spot it's not a storm in the sense of like what a hurricane is on the U.S. I mean, on Earth, it's not a massive low pressure zone. It's a massive high pressure zone. So yes, the winds are very high, but think about it. On a clear sunny day when there are no clouds, isn't it often windy on such a day? The answer is yes. This is part of the reason why we don't like to launch spacecraft on perfectly clear days, because if the pressure is too high, the atmosphere is literally denser and you get more static electricity and the higher likelihood of things exploding and so on. Because of static. And hopefully you're not watching channels on YouTube that put out static and don't understand basic physics. It's very sad what people consume on YouTube and say that it's science, as there is a lot of nonsense disguised as science on the internet. So many cults. Anyway, let's get on to CMEs. And there's another one headed toward Earth. So always excited about that. With 3 on the way, folks. 3 on the way. And a coronal hole high-speed stream right at the end of the first 2. So it's just awesome times for space weather. And expect it to continue. So here's our last go C2 and C3. Except no substitutes for the daily space weather show. There ain't nobody to compete, folks. Only posers who we don't even need to beat, folks. They're just beating a dead horse and themselves up. So, now, here's one of the things that happens. When you have the Solar Orbiter and Bepi-Colombo and the Parker Solar Probe all on the far side of the sun, you get less data. So you have to rely more on the instruments that we have that we show every day on the channel. You got to look at the coronagraphs, the SDO imagery, the GOES-16, SUVI, the various different ground-based solar telescopes can help because you see filaments disappear. It can be very deceptive, and we've been seeing a lot of filaments erupting that are extremely concentrated, meaning they're not dissipating very quickly. Sometimes when a CME happens, it just dissipates right away, and sometimes it comes out in a long, stringy filament. Sometimes it looks like a fist coming out of the sun or something like that. So, you get very, very different types of CMEs, and some of the strongest hits are going to be the ones that don't produce a halo sometimes, because if it's if you have diffuse gas that's flying through space directly toward you, you might not see a halo from it ever. It might be too far out of the corona that it will not show up. So that's part of the way that we forecast CME impacts. So anyway, there's stereo A and its difference imagery, and this one CME that you're seeing here out of the south-southwest, that is earthly directed. So hold on a minute, let me advance this. We never know what data we'll get when we run that. So I think it's that one right there, the one that looks like it's coming out of the due south. That is likely to have an earthly directed component. So it showed up around 7 o'clock this morning, something like that. And here come our custom coronagraphs. They are there we go, I've reappeared. Cheers. So there's our custom coronagraph, and you're going to see a massive filament motion. Oh yeah, there is a partial halo there out of the south. So yeah, I mean, that sunspot's a little bit to the south. That is absolutely earthly directed. A large portion of it will be striking Earth. That'll be, on the 25th. 25th, maybe late in the day on the 24th. But it doesn't look particularly high speed. So that's a 24-hour video, by the way. Yeah, actually 2 events there. One quite early in the morning. They might both be earthly directed. Let's see. First one, yeah, they both are. So yeah, 2 more. So that makes 4 CMEs on the way. And yeah, I mean, they've been rolling in basically as we forecasted. So cheers. You would think NOAA and NASA and the ESA would watch the channel, but whatever. I mean, like, look, it's not too easy to get 5,000 subscribers on YouTube, folks. And please, viewers, leave us a comment and let the other viewers know the level of accuracy that this channel has had, both in meteorological forecasting and in space weather forecasting for the past 5 years. Please leave a comment. Let folks know, back us up, about the dissemination of factual information. So yeah, there you can see those CMEs. They're both out of this sunspot group. I mean, what can you say? 2 more on the way. That's what I'll say. Now, we're going to close out our custom imagery here. This is a 48-hour video showing just the southern hemisphere because that's where the action has been. So yeah, there you go. Enjoy. We're going to blast through meteorology at speeds you would not believe. Space weather bonus features have been canceled as there are weather warnings. Let's do it. So here comes meteorology. And the first thing we're covering is not that or that. The aurora. We ain't got none. It's very chill as far as the aurora go. Here's our satellite imagery for the Western world. And yeah, that's the visible satellite for the goes east. Love it. Absolutely splentacular. So here's our warning map. And we've got a bunch of severe weather warnings there in the northern central part of the U.S., also the Michigan and so on. If you've got weather warnings, check out weather.gov. We've got a bunch of freeze and frost warnings, mainly frost warnings in the northeast. So heed those. Put some straw on your plants. Put plastic. Do things to prevent them from freezing tonight. If you enjoy the content, press the like button. Leave a comment. Press share, etc. Here comes our our couple of tropical tidbits forecasts here. Tropicaltidbits.com is where we typically show our GFS forecast from. There's the temperature anomaly forecast in degrees Celsius for the next 72 hours. 72-hour GFS pressure and precipitation forecast as heavy moisture moves in to the northeast from the Great Lakes states. So all good things have to come to an end, and things like warm weather at this time of year are one of those things. There's our lightning map from Lightning Maps. That's what is it? It's the Sierra. It's whatever. It's lightning for the past like 10 hours. Here's a real-time lightning map from lightningmaps.org. And it looks like South Florida's got some thunder rolling in. Miami Beach. Let us know in the comments if there are water spouts off of your coast. Shout out to that kid from Miami. The heck is that kid's name? I can't remember. Anyway, we hope you're doing fine. Anyway, there's our U.S. Doppler radar map. There is our satellite imagery. There is water vapor. Here's a recap. That's vertical motion in the air column, known as the Doppler radar, a ground-based system. Space-based system showing visible satellite. What you would see with a black and white camera from space. Of course, we do have the states superimposed on there and islands and so forth. And there's the water vapor map, and here's me signing off. I've been your host, Dan, a.k.a. Smash and Mash. See you next time. And in the meantime, may that solar wind be at your back. What?